This storm has already hit 3 different countries, killed people in 2 of them, and forced nearly 30,000 soldiers onto standby. And it's still not finished. Typhoon Bavi became the 3rd Category 5 storm of the year, tore through the northern Mariana Islands at 180 miles per hour, buried Philippine mountainsides in landslides, and is now dumping so much rain on China that rescuers are pulling people off the roofs of submerged cars. Scientists studying this storm are saying something that should genuinely concern you, and we're going to get to that in the next 3 minutes. Don't go anywhere. Here's the fast version of what you need to know before we go deep. Bavi formed in early July 2026 in the open Pacific, and it did something only 2 other storms have managed to do all year. It exploded into a full Category 5 super typhoon. Peak winds hit 180 miles per hour. Central pressure dropped to 901 hectopascals. For comparison, the lower that number goes, the more violent the storm. And 901 puts Bavi in the same range as some of the most destructive typhoons ever recorded in the Pacific. That's the headline number. But the real story is what happened after. Because this storm didn't just hit one place and fade out. It's been on a rampage across 4 countries, and each stop has been worse in a different way. The first target was Guam and the northern Mariana Islands. And this was actually the 2nd time in 3 months a powerful typhoon had crossed this exact chain of islands. On the night of July 5th, Bavi passed directly over Rota, one of the Mariana Islands, at peak intensity. NASA satellite imagery captured the moment. A massive, well-defined eye illuminated by moonlight, with the surrounding eye wall glowing in infrared as it churned directly over the island. Guam's governor had already declared a state of emergency days earlier. Flights were grounded at the main airports, and port operations were suspended entirely. When Bavi hit, it downed power poles and lines across the region, flooded roads until they were impassable and littered with debris, and damaged critical infrastructure, including a water distribution station on Rota, meaning the storm didn't just cut power. It threatened the water supply for an entire community. Officials had warned residents to expect up to 12 inches of rain, enough to trigger flash flooding on top of everything else the wind was already destroying. And here's the detail that surprised even meteorologists tracking the storm. Bavi briefly weakened overnight before Guam through something called an eye wall replacement cycle, where a storm's inner eye wall collapses and a new one forms around it, and then it re-strengthened almost immediately, hitting Rota at its absolute peak intensity anyway. In other words, the storm tried to weaken, and it didn't listen to its own physics. Sea surface temperatures in the region were sitting around 30 degrees Celsius, roughly 86 degrees Fahrenheit. At the time Bavi was intensifying, warm enough to act like rocket fuel for a storm system. Warm ocean water is the single biggest energy source a typhoon has, and satellite observations tracking Bavi's development showed it pulling from exactly that kind of heat as it moved west, which is part of why it climbed to Category 5 as fast as it did. Storms don't reach 180-mile-per-hour winds by accident. They need a very specific set of conditions lined up, and in early July 2026, the Western Pacific handed Bavi almost everything it needed. But Guam wasn't the end of this. It wasn't even close. Because while the islands were still cleaning up power lines, Bavi was already reforming its path toward a chain of mountains where the real body count was about to start. What happened next in the Philippines killed more people than the typhoon's wind ever touched. And the reason why has almost nothing to do with the storm itself. It has to do with an earthquake that happened months earlier. Here's where this story turns from big storm into something scientists specifically flag as a compounding disaster, meaning two separate hazards stacking on top of each other to create damage neither one would have caused alone. Bavi didn't make direct landfall in the Philippines. Instead, its outer rain bands combined with a southwest monsoon system to dump extreme rainfall across the southern island of Mindanao. On its own, that rainfall might have caused flooding, but the ground underneath it had already been destabilized by the 2026 Mindanao earthquake months earlier, meaning the soil was already loosened, already weakened, already primed to fail the moment enough water hit it. In the village of Pandao, in the municipality of Malapatan, that combination triggered a landslide that killed 10 people. In a separate location, Calanogas, in Lanao del Sur province, another landslide attributed to Bavi's rains killed 7 people, injured 2 others, and left 4 more missing. Serious enough that officials declared a state of calamity for the area. 2 more bodies were later recovered in Bukidnon province. Across the country, the confirmed death toll from Bavi's rains and landslides climbed to at least 17, with 9 others still listed as missing. This is the part meteorologists want people to understand, and it's not intuitive. A typhoon's most lethal impact often isn't the wind at the eye of the storm. It's the rain falling hundreds of miles from the center onto ground that's already unstable, in mountainous terrain, where there's nowhere for the water to go except downhill, fast, and without warning. Bavi never even made a direct hit on Mindanao, and it still became one of the deadliest parts of this entire storm's path. This is what disaster researchers call a compound hazard, and it's becoming one of the most important concepts in modern disaster science. Individually, an earthquake and a tropical storm are 2 completely separate categories of hazard, tracked by different agencies, modeled with different tools, and usually discussed in entirely different conversations. But geology doesn't reset on a clean timeline just because the news cycle moves on. Soil weakened by an earthquake can stay unstable for months, sometimes longer, especially on steep terrain. When a storm like Bavi arrives during that vulnerable window, it isn't hitting a landscape in its normal state. It's hitting ground that's already primed to fail, which is exactly why a relatively indirect rainfall event turned into multiple fatal landslides across separate provinces within days of each other. Meanwhile, across the sea, an entire country's military was already mobilizing for what officials were calling the most dangerous storm to threaten the region in years. Because by this point, nearly 30,000 soldiers had been put on standby in a single country, and the storm hadn't even made landfall there yet. As Bavi tracked west, it grew into a genuinely massive system, at its broadest extent, roughly 1,000 kilometers wide, which meteorologists pointed out was comparable in size to the entire country of France. A storm system that large doesn't just hit one coastline. It smothers everything in its path for days. Taiwan's government put approximately 29,000 soldiers on standby, positioning them for what defense officials described as potentially the strongest typhoon to threaten the region since a previous storm in 2024 that had claimed 3 lives. Forecasters warned that rainfall in the mountainous regions near Taipei could reach up to 1 meter. That's over 3 feet of rain in a mountainous region already prone to flash flooding and landslides, the same lethal combination that had just devastated parts of the Philippines days earlier. Before reaching Taiwan, Bavi swept extremely close to Japan's Sakishima Islands, a remote chain in Okinawa Prefecture near Taiwan. Japanese meteorological authorities warned of violent winds, torrential rain, landslides, and flooding, describing it as potentially the region's most destructive storm in years. On Ishigaki Island, residents were seen taping up windows and stretching windproof netting across homes and storefronts. The kind of last resort preparation that tells you exactly how seriously local authorities were taking this system. Reports from the islands noted a dozen or more injuries in Okinawa Prefecture alone, as the storm's outer bands moved through. One tropical cyclone researcher tracking Bavi's development, based at Imperial College, made a point of noting just how long this storm had been intensifying over open water, pulling energy from unusually warm sea temperatures and storing enormous amounts of moisture the entire time. That single detail, a storm feeding on warm water for an extended stretch before ever reaching land, is exactly the kind of pattern that was about to make China's experience with Bavi far worse than anyone expected. There's also a broader context worth pausing on here. This wasn't an isolated freak system appearing out of nowhere. Regional climate researchers had already been warning, before Bavi even formed, that this year could bring catastrophic storms testing the resilience of China and its neighbors. A warning that, at the time, was based on developing ocean conditions rather than any specific storm. Bavi arriving as a Category 5 system just weeks later isn't proof that the warning was correct in every detail, but it's exactly the kind of event those warnings were describing. And this is where we get to the part that actually stunned scientists. Because what happened after Bavi made landfall in China wasn't supposed to keep happening days later, hundreds of kilometers from where the storm actually hit the coast. Bavi made landfall on the eastern coast of Fujian province in China after brushing past northern Taiwan. On paper, that's where the story should have started winding down. A typhoon makes landfall, it weakens over land, the danger fades within a day or so. That's the normal pattern. That is not what happened. In Hebei province, hundreds of kilometers inland from where Bavi actually made landfall, Jiangxi County recorded nearly 190 millimeters of rain, roughly 7.5 inches, in a single overnight period from Saturday into Sunday. Footage verified by Reuters showed rescue teams using an inflatable boat to reach people who had climbed on top of a partially submerged car after floodwaters turned a public square into what witnesses described as a muddy lake. Here's the sentence that should stop you. Even as Bavi weakened after landfall, its large circulation kept generating destructive weather hundreds of kilometers inland. That's not normal typhoon behavior. Most storms lose their punch fast once they cross onto land, cut off from the warm ocean water that fuels them. Bavi kept producing serious, life-threatening flooding well after it was technically classified as weakening, far beyond where its own landfall point would suggest the danger should have ended. This is precisely the detail that has climate researchers on alert. The dean of the School of Energy and Environment at the City University of Hong Kong, who has been tracking the storm's behavior, pointed directly at a bigger pattern. Scientists are warning that China could face more extreme weather this year with the expected emergence of El Niño, a climate pattern that can drive up ocean and air temperatures and shift typhoon tracks further west, directly toward China's coastline, instead of curving harmlessly out to sea the way storms in this region sometimes do. And there's a second warning buried in that same research, one that applies far beyond this single storm: rapid intensification, a storm exploding in strength over a short period. The exact thing Bavi did on its way to Category 5 reduces preparation time for communities and emergency managers, making these events particularly difficult to plan for. When a storm takes days to build strength, coastal regions have time to evacuate, stockpile supplies, and mobilize response teams calmly. When a storm intensifies rapidly, like Bavi did, that entire preparation window shrinks, sometimes to less than 24 hours. Put those two warnings together, and you get the actual reason scientists are stunned by this storm. Not because Bavi did any single thing that's never happened before, but because Bavi is now the third storm this year alone to reach Category 5 intensity. 3 storms. Same year. Each one represents the maximum possible category on the scale meteorologists use to measure tropical cyclones. That frequency, that many extreme storms in a single season, combined with a storm that kept flooding communities hundreds of kilometers past its own landfall point, is exactly the kind of pattern researchers have been warning could become more common as ocean temperatures continue climbing. It's worth being precise about what third Category 5 of the year actually means, because it's easy to hear a number like that and not register how unusual it is. The Saffir-Simpson scale, which meteorologists use to categorize hurricanes and typhoons by wind speed, only has 5 categories, and Category 5 is reserved for the most extreme storms on the planet. Sustained winds of 157 miles per hour or higher. In a typical year, the Western Pacific and Atlantic combined might see 1 or 2 storms reach that threshold, if any. Seeing 3 separate systems hit that ceiling in the same year, with Bavi crossing multiple countries on its way there, is the kind of statistic that shows up in end-of-year climate reports, not something researchers expect to be discussing again before that year is even half over. So what does all of this actually mean for the millions of people still in Bavi's path, and for the seasons of storms still to come? Let's put the full picture together. Let's recap the actual scale of what one storm did, country by country, because laid out together, it's genuinely rare to see this much damage from a single system. In the Mariana Islands, Bavi hit Rota at peak intensity, downing power infrastructure and threatening the water supply for an entire community. In the Philippines, its outer rain bands combined with earthquake-weakened soil to kill at least 17 people in landslides, with 9 more still missing. In Taiwan, nearly 30,000 soldiers were mobilized. Even mountain regions braced for over 3 feet of rain. In Japan's Sakishima Islands, residents in Okinawa Prefecture boarded up homes for what was called the region's most destructive storm in years, with reported injuries in the dozens. And in China, the storm's circulation kept flooding communities hundreds of kilometers inland, well after landfall, forcing dramatic water rescues on camera. 4 countries, multiple confirmed deaths, tens of thousands of displaced or affected residents, military mobilization on a national scale, and a storm that technically is still weakening as we speak, meaning the flooding in China and the rainfall threat further inland aren't finished yet. The scientific concern here isn't really about Bavi as an isolated event. It's about what Bavi represents. 3 Category 5 storms in a single year is an unusually high number, and researchers studying ocean temperature trends have been direct about the connection. Warmer seas hold more energy, and that energy is exactly what fuels both the intensity typhoons reach and the speed at which they get there. Rapid intensification isn't just a technical term for meteorologists. It's the difference between a coastal community having a week to prepare and having less than a day. That's not a comfortable pattern to sit with, and it's also not something any single video can fully resolve. What we can do is keep tracking storms like this one honestly, with real data, so that if this pattern continues, more Category 5 storms, more rapid intensification, more flooding far beyond where a storm actually makes landfall, you're seeing it documented in real time instead of finding out after the fact. There's one more thing worth sitting with before we close this out. Every single country Bavi touched had some form of warning system in place. Guam had a state of emergency declared days in advance. The Philippines had landslide monitoring in earthquake-affected zones. Taiwan mobilized troops before landfall. and China's meteorological service had been tracking the storm's path for over a week. None of these countries was caught by surprise in the way a community with zero warning would be. And it still killed people, displaced tens of thousands, and produced flooding hundreds of kilometers from where anyone expected it. That's not a criticism of any single emergency response system. It's a reflection of just how much energy a Category 5 storm carries, and how even well-prepared regions can still be overwhelmed when a system this powerful moves through. So here's where things stand right now. Typhoon Bavi has already caused confirmed deaths in the Philippines, mass displacement and infrastructure damage in the Mariana Islands, historic military mobilization in Taiwan, destructive impacts across Okinawa Prefecture, and ongoing, unusually persistent flooding hundreds of kilometers inland in China. Flooding that, notably, is still happening even as the storm itself weakens. Scientists are watching this storm not just for what it's already done, but for what it represents. The third Category 5 typhoon of the year, arriving amid warnings about El Niño-driven extreme weather and the growing challenge of rapid intensification, giving communities less and less time to prepare. Let's do one final gut check on the numbers, because they're worth hearing back to back. At least 17 confirmed deaths and 9 missing in the Philippines. Nearly 30,000 soldiers mobilized in Taiwan. Up to 1 meter of rain is forecast in Taiwan's mountains. A dozen or more injuries across Okinawa Prefecture. Nearly 190 millimeters of rain in a single overnight period in inland China, far from where the storm made landfall. And 3 Category 5 storms total this year, with months of typhoon season remaining. Individually, each of those numbers describes one country's experience with one storm. Together, they describe exactly why meteorologists tracking Bavi kept using words like unprecedented and alarming, instead of the more routine language usually reserved for a typhoon making its way across the Pacific. We're going to keep following this storm's aftermath, along with the broader pattern of extreme typhoons this year, because storms like Bavi don't stay contained to one news cycle. The flooding in China alone could continue for days. If this video helped you understand exactly why scientists are calling this storm's final strike so alarming, hit subscribe because we're covering the next major weather event as it develops, not after it's already over. And if you want to see how this exact pattern, storms and disasters compounding on top of already weakened ground, connects to what we covered in our Venezuela earthquake video, go check that out next. The pattern is the same, even when the disaster type is completely different. Thanks for watching. We'll see you in the next one.